Hello everybody, my name's John and I'm going to be taking you through the Teaching Negative Numbers presentation today. So, why are we starting with negative numbers? Well, firstly I wanted to pick two topics for the first introductory week which both appeared in primary school in Key Stage 2. And negative numbers and the other one, longer multiplication, they both appear before they've even reached secondary school. So, when they arrive, you can hope that they will have at least seen the concept of a number line. They will have done simple addition with a negative number maybe, but they won't have done some of the more awkward kind of ideas that you meet in secondary where you've got a series of minuses and pluses. That said, of course, even the very brightest kids, when they get to secondary school, they seem really quite confused by negative numbers, and you can understand why. It's not an easy topic. Now, this is shown by my next point, which is that it's incredibly important to get negative numbers right if you want to have any success with algebra. And so, in the GCSE there's lots of questions like, factorising quadratics or solving simultaneous equations where you must understand negative numbers if you've got any hope of getting those marks. So, and that brings me nicely to my third point, which is that all of us have made hundreds if not thousands of mistakes with negatives in our life. It's something which is what I would describe as a careless error. And so, how do we cope with students making these careless errors when we're making them ourselves quite often? That is a tough question, and one I hope to answer towards the end of the presentation. This brings me really nicely to my fourth point, that is, it's even rudimentary mathematics, like negative numbers and long multiplication. They can actually be quite complex topics, there's no doubt about it. They're difficult, and when you get asked some searching questions by students, it can be very difficult to give good answers. And really, the more you read, the more you look, the more you see other teachers teach, the more you slowly sort of get an idea for what is a good explanation for why two negatives make a positive, for example. So anyway, that's the kind of thing we're going to be looking at for the next 15 minutes. So, when teaching negative numbers, I like to give a little bit of a historical context to where negative numbers came, when they arrived, why they arrived, what purpose they were used for. Now, that's why I've got the slide of Brahmagupta. He was the Indian mathematician who discovered negative numbers. He's quite an interesting guy. He was an astronomer as well. And if you read his 11 lines of how to deal with negative numbers, the negative number obviously is a debt, the positive number is the fortune. He gives just a system of rules there, surely just a system of algebraic rules for coping with negative numbers. Now, I also think that you can have a bit of fun with the students on this kind of topic, because you can ask them questions like, do they think negative numbers are real? You can do that even before you introduce the topic right at the start of the lesson. Lovely little starter activity for 1 minute or two. Do they think negative numbers are real? Because you'll often hear some really interesting answers, and you can certainly give them some really challenging points as well. Students will often argue that they aren't real because you can't have -3 sheep, or you can't have a negative length, so on and so forth. And funnily enough, that's exactly what the ancient Greeks thought. So they're in good company, they really are. I mean, it doesn't make any sense in many ways, and especially for the ancient Greeks, who were geometers, all they cared about were positive lengths. They didn't have any room in their mathematics for negative numbers. As a result of this, even though negative numbers appear almost in the complete middle of our Venn diagram of types of number, they were actually one of the last types of the number system to be accepted. I mean, the rational numbers which you see outside of the integers, well, the Greeks understood those. They were quite happy to deal with rational numbers. They thought the whole universe was rational. What the Greeks didn't like also were the real algebraic numbers like root 2. They knew about them, but they thought that they would be rational, or many Greeks did anyway, the Pythagoreans. You've then got the reals outside of that, and the complex numbers, which certainly come up at A level. Now, if you want to give sort of like a very bright, like year 10 or a year 11 class something to think about, you can start talking about the growth of the number system and the way mathematicians were really stumped by lots of these numbers when they were first produced. Now, why were we stumped by real numbers, or numbers which have non-terminating decimals or can't be expressed as fractions? The irrational numbers. Why were they freaking us out originally, just like the negative numbers are? Well, the reason is because surely they weren't considered in some way, relevant to reality. When you think about a real number, a non-terminating decimal, it means it can't be found on the number line. That's a really strange concept. And when you get to the complex numbers on the very outside, well, they're called, they're imaginary numbers. They're complex numbers. They are, surely the opposite of real numbers, which is why they lie outside the real circle. Now, you may prefer not to give your students this philosophical discussion on negative numbers at the start of the lesson, and that's fine. The reason I choose to is because I know they're going to be doing a lot of just, tough mental calculations with negatives for the rest of the lesson. So it's nice to have a little chat in many ways at the start about, what we're really handling here. But let's look at what the students actually really need to know. Well, they certainly need to be able to order them on a number line and manipulate, the various symbols which you might use: less than, greater than, the inequalities, equal to and not equal to. That's fairly straightforward and is covered really in Key Stage 2, but anything covered in Key Stage 2 can be covered in Key Stage 3. Anything covered in Key Stage 3 is obviously also part of Key Stage 4. Worth remembering that, there's nothing which couldn't appear later on. There might be one or two topics actually, but I think they're changing that. Anyway, there you need to use the 4 operations: add, subtract, multiply and divide negative numbers. And they also need to handle negative numbers with standard form. That can often cause problems as well, but really that's just a small subset of what they need to do later on in Key Stage 4, because they'll need to handle indices, negative indices, and that's certainly something they find really quite tricky. Now, you'll see at the bottom of Key Stage 3 and Key Stage 4 this funny little sentence, the 4th line, which has suddenly appeared in the syllabus. Appreciate the infinite nature of the sets of integers, reals and rational numbers. Now this actually ties into the diagram which is just on the previous slide. Surely that is the previous slide. I mean, I've never seen any questions in the GCSE up to this day about anything like the infinite nature of the sets of integers, reals and rationals. That sounds really quite advanced. Now I'm certain they won't expect anything ridiculous from them. I would imagine that little sentence in there just means that they'll need to appreciate that they're all infinite and that in itself is just a fact. I don't see how they could easily test that, to be honest with you. And yeah, in Key Stage 4 you've got negative and fractional indices as well. Now really that doesn't do it justice. It sounds like negative numbers is almost not that important, but if you just work through any past higher tier GCSE paper, you will find plenty of questions where if you're not really okay with your negatives, you're going to become rapidly unstuck, and that is the issue to me. So simultaneous equations, quadratic equations, when you're solving them, you need to be really strong on your negatives. Anyway, let's take a look at 10 common mistakes on the next slide. Here I'm presenting you with 10 common mistakes as I see it. Now, you see all of them all of the time really, but I've picked 2 out of those 10 which I believe reveal real confusion, and I'm about to talk about 2 of these 10 mistakes. I wonder if you can guess, if you just want to pause the video, take a look at them all, guess which 2 I'm going to talk about as the 2 mistakes which I think worry me the most in many ways, because they're not just careless slips, they're actually real errors of understanding. See if you can spot those 2. Pause the video for a moment. Okay, hopefully you've jotted a couple down. In a couple of slides time I'm going to go through what I think are the most confusing ones. I mean, we may agree, we may disagree, it doesn't really matter, it's just a bit of fun. Okay, let's just remind ourselves very quickly of the rules of negative numbers. I'm sure you'll remember that like signs obviously are positive when they're next to each other, and unlike signs are negative when they're next to each other. That applies both for adding and subtracting, but also for multiplying and dividing. The rules don't change for multiplying and dividing, and these rules are simply Brahmagupta's rules, but just written in algebraic form. Rather than using debts and fortunes and words, we're using the basic rules of arithmetic. Now, I'd like you to do something else for me right away as well. Imagine you're in the class and the question's bound to come. Someone's going to ask you, but why do 2 negatives make a positive? Now, I'm thinking of the situation here when we're subtracting, so 5 minus negative 3. Why is it there that it becomes 8? Why do 2 negatives make a positive? Pause the video and quickly jot down an answer to that, and then I'm going to tell you Personally, what I say, I don't think it necessarily is the best answer by any means, but you might like it. Just have a little think to yourself though. You're put on the spot, what would you say? Okay, I hope you've had a little think about it. Now, what I like to say, these are reasons I give, some of them certainly seem to work, I hope they do anyway. The first reason I give is, if we negate a negation in language, it becomes a positive. So, like I say, if we lose a debt, the result is a net positive for us. You have no longer got to pay back some money. That is a positive. But the one I really like to use, particularly because I teach in Essex, so we've got the Estuarine dialect, and you might hear this in your classroom: I ain't done no homework. Well, that means surely they have done their homework, because they haven't done no homework. And if you haven't done no homework, then you've done some work. So I like to give them that example. That's nice because it relates to just logic, really. That's what I'm using there, because this is really where the negation of a negation comes from. I think it's really embedded in logic, but they use that in English, and so sentences like that, the grammar there, it's using the double negative. You can also use the number line to justify it as well. It will make obviously little sense. If I was doing 5 minus 5, and obviously that's 0, well, if 5 minus minus 5 was also 0, the first thing I'd say is, what's the point of negatives then? They don't do anything else. They're not new numbers. And so if they go to exactly the same value under subtraction as positive 5 does, like I say, it means subtraction actually becomes a one-to-many function, and that's that's actually a real problem. It's A-level stuff, but it can certainly cause issues. You want just one answer to 5 minus a particular number. If two different numbers give you the same answer, it becomes a many-to-one function, and that's a real problem. But yeah, I'd love to hear if you've got any better reasons. It's really tough to explain, I think. The lesson plan, which I've got coming up in the course from another teacher who explains it, I think he's got a lovely way of doing it. I really do. But there's lots of different ideas out there. I certainly don't think I've got the best ones. If you've got a better one, let me know in the forum. Okay, let's talk about which of the 10 mistakes you picked for revealing genuine confusion. The one I've picked, and I reckon some of you would have got this, is -3 minus 5 equals 8. You hear that all the time, and you'll hear students say, but there's a double negative there. Surely that becomes positive. And it's a serious bit of confusion, this. It's worth pointing out that negative and negative only become positive if you're A, multiplying them, or B, they're next to each other in an addition or a subtraction. Or obviously in division as well, I should mention that. But I like to look at -3 minus 5 like this. I always like to explain it like this. Lose 3, lose 5. It means you've lost 8 overall. It makes a lot of sense. And in fact, if you have any negative number, any statement with -3, +7, -9, -2, you can just look at that as, a series of losses and gains, and you always get the right answer like that. It also gives the right meaning to what negative numbers actually are. So I honestly believe as well that's probably what Brahmagupta would have said. Maybe not. But yeah, possibly. Okay, the next genuine confusion I've seen, and this is kind of weird. I was really surprised when I first saw it when I got into teaching, but it's because of something called BibMaths now. Now, I don't even remember BibMaths when I was at school. I think we had something called BMA, just brackets, multiplication, addition. But yeah, BibMaths is what they're all using now. Now, people often wrongly assume that the D and the M, that division takes priority over multiplication. Well, I know there's different ways of sort of writing it, but technically, really, that's not true. And certainly, for addition and subtraction, there is no reason that you have to do addition before subtraction. Division and multiplication are of equal rank. Addition and subtraction are of equal rank in BibMaths. So it means brackets, indices, then division or multiplication, whichever one you want to do first, then addition or subtraction, whichever one you really want to do first. So yeah, obviously, what is 5 minus 3 plus 2? What they're doing, I presume, is thinking, I need to add before I subtract, and therefore doing 3 plus 2 first is 5, and then doing 5 minus that 5 and getting 0. That's another serious, it shows genuine confusion if they're making that mistake for that reason. I like to look at it like cut up numbers, and once again, we can look at that, 5 minus 3 plus 2 as gain 5, lose 3, gain 2. Yeah? And that can be cut up in any way you like, as gain 5, lose 3, gain 2. It could be lose 3, gain 5, gain 2. It could be gain 5, gain 2, lose 3. They all equal overall a gain of 4, and therefore the answer is positive 4. That's why the sign before the number sticks with the number. It's because of the meaning of these things. See if you can get across really what it means. The rest of the mistakes, the other 8 out of 10, I still see all the time. So what are they down to? Well, carelessness. Absolute carelessness, which we all do. I've done it, you've done it, everybody does it. Now, really, there's only one kind of medicine for something which can, for just sloppy mistakes and things like that, and that is practice, practice, practice. Now, I've got a little video of myself on a little image package back at home, drawing something which I would draw up on the whiteboard at work. So if you'd like to just click on this link, you hopefully will enjoy this little video of me taking you through a technique I use very regularly. Okay, I hope you enjoyed that, or could at least see the benefit of it. I just want to take you through 4 reasons why I like this activity. There are loads of activities like it, by the way. You don't have to use this exact one, but I find something like this done once a week or once every 2 weeks with like classes in years 7, 8 and 9. It works really well. Okay, so why do I like it? For lots of reasons. Firstly, it practices using negative numbers under addition or multiplication. That's a primary reason, but it also practices times tables, so you've got basic arithmetic constantly being used. That's brilliant. Times tables are like negative numbers. If you don't use it, you lose it. It's really quick to do. It gives you, once they're really trained, a really peaceful start to the lesson where you can get your register done, get your books in order, get ready to sort out any other resources you might need to give out. The next reason is the students actually get really quite competitive, and I work in an all-girls school, and girls can be quite competitive. I tend to find boys are more competitive, but the girls I work with, they really enjoy competing, trying to get their sort of, I sometimes put their names on the wall and that kind of thing. The next reason I like it is because it requires 0 preparation, and in our busy lives it's always appreciated. And finally, I like it because it really trains them at the start of a lesson to just get their heads down and do a bit of maths. It's a short, sharp, crisp start to the lesson. It's not the sort of thing you want to do just off the cuff for the first time, in front of an observer or anything like that, because it only really works once they're trained, which takes about 3 or 4 work throughs of it, 3 or 4 weeks really. But that really completes the little talk I wanted to give on teaching negative numbers. I'd be very interested to hear any of your thoughts on how you would, any resources you've got for teaching negative numbers, or any thoughts you've had on how you would explain why 2 negatives make a positive. Any thoughts on negative numbers at all. Thanks for listening, and I hope that helped.